All right, for our third speaker this time, slot in the Turbo Talks, I'm going to steal his first slide as well. It is Kash Kiani. He's going to be telling us about Auth.
Good afternoon, everyone. First, I'd like to thank you all for coming to this talk, especially since you have plenty of other options with all the great tracks that are going on at the same time. So yeah, my name is Kash Kiani. I'm an application security consultant. I do pen testing, security architecture, general consulting, and recently I've had a couple opportunities with a few clients to work with their Auth implementations, and that's what we'll be talking about today. So we'll be spending the next 20 minutes talking about Auth. We'll cover this emerging protocol at the high level, provide some context, and go over a typical Auth flow. Then we'll show you a few sample applications and show you how easily you can inject your own malicious code into these apps and basically do evil things with them. And then we'll shift gears a little bit and talk about a few questionable implementations. And the goal here is that as security professionals and OAuth developers and implementers, we learn a few things that hopefully we can take it back to our organizations and apply them accordingly. Then we wrap it up with a quick summary. And then after that, I can answer any questions that you might have, and I can also stay off podium and take questions. We have a lot of slides to go over, but I think they're pretty lightweight. So what is OAuth? OAuth is a permission-based authorization scheme that allows one app to access your protected resources or services on a different app. And that's really the gist of it. If you've used any third-party Google, Facebook, Twitter apps, you probably use OAuth. So the standards committee and the OAuth community typically uses the valet key analogy to describe a typical OAuth flow. I guess with the valet key, you can access certain parts of a car. You can access maybe the glove compartment, not the trunk, or maybe you can drive the car for X number of miles before it shuts down or something like that. I don't know. I've never used the valet key before. In fact, I live in Oakland, and our valets don't need a key to get to your car. So instead, we use a banking statement or banking use case. Here we have our main actor in this use case, Avon Barksdale. He's not a valet. He's a fictional character from the TV show Wire. You might know him. He's my favorite gangster. So Avon banks with AIG and Freddie Mac, and he wants a third-party client app like Mint to access his AIG and Freddie Mac on a limited scope. For example, he wants Mint to consolidate his checking statement so he can refi his mansion in Baltimore. So instead of giving Mint his banking credentials, he creates an access token with specific scope and permissions and gives it to Mint. The Mint can use that to access the protected resources on the server, which is AIG and Freddie Mac. Same thing with his social networks. So there are various third-party Twitter clients in this example that Avon wants to use to access his Twitter account on his behalf to do something. Post a tweet, post an RSS feed, read a tweet, do something with pictures. So again, instead of giving this third-party apps his Twitter credentials, he signs a specific token with specific permissions to assign them to third-party apps to access his Twitter account. So to provide some context, you got to go through actors that we're going to be using throughout these examples. So if you have a user, in that case was Avon, he owns the resources. We have a third-party client application which consumes the resources. It's usually a web-based or a mobile app. And we have a server that provides the resource or provides the service. And tokens are all over the place. We have the consumer credentials that are used by the third-party client app to access, to authorize itself to the server. And we have the request token and access token and refresh token. So we'll talk about these tokens a bit more in the use cases, but the request token and access tokens are kind of like user ID and password. The access token is short-lived, and then you use a long-lived refresh token to refresh your access tokens. The typical OAuth flow is pretty involved, but here we have simplified in 4 separate steps. So the first thing you do, as a third-party client, you authenticate yourself to the server and use the consumer credentials to do that. After that, you get a request token from the server, and that's used for directing the user to the proper authorization endpoint on the server. So once the user provides authorization and consent, then an authorized token is created, and that's the access token. And the access token is given to the third-party client application that can use for ongoing access to the protected resources via API calls. And then you have that refresh token we just saw earlier to refresh these access tokens. Again, we'll see these a bit more later. So let's talk about a few malicious apps. Here we show you how easily you can build a third-party client app to do malicious things, or get one and inject your own malicious code in there. So if you have a install iOS app and a browser-based web application that will be showing you, and if you need the entire source code, you can email me. I can send you all the source code after the talk. So this one is install iOS app that we use to steal Google credentials. So the first thing you need to do when you start your OAuth project, you build your third-party client app from scratch, or in this case, we've downloaded the OAuth Sample Touch mobile client from Google, which basically connects to a Google server and to read your Google Reader account, basically a Google authentication. So we went and made a few changes in the main controller class that deals with all the UI web view and all the delegation functionality. So basically what we're doing here, we are intercepting the request before it's posted to the Google's login page. So as you can see in the highlighted area, we're grabbing the HTTP body, we're assigning it to a string, then we're creating an array of string and iterating through this array based on the prefixes email and password, which is your Google username and credential. We log in that, and that's it. So this is a native app, and we're not confined within the context of a browser, so we don't have to worry about same origin policy and things like that. And while we're doing this, the user is going through a typical OAuth flow on their mobile device, not knowing that in the background, we're grabbing their credentials. Here, we just log in it, but you can easily send it to a backend web server. So the problem is that OAuth provides the user with a false sense of security around this entire authentication authorization workflow, because everything looks legitimate, everything looks as if you were doing this within a trusted context. So these recommendations are from a pure security perspective. We're not really considering usability. For instance, the first one, that might diminish the user experience, but it makes sense from a security perspective. So if you're a third-party client app developer, don't do what we just did. So manage the authentication flow outside the context of your rich client and a third-party neutral app like Safari. And if you're a user, well, if you don't trust an app, make sure you don't provide your authentication within the app, within the rich client app. And a lot of these issues that you're seeing are because of the fact that the clients cannot properly authenticate themselves to the server. So we need better, stricter policies around the entire client-server authentication. And we'll talk about this when we go over the consumer credentials. So this is a third-party OAuth web-based application that we use to do some social engineering. Basically, we use to get some information about the user, then we can use that sensitive data to launch another attack. So the first thing we do, we build our app. Then in this use case, we are basically launching a simple phishing attack with social engineering toolkits, part of municipal framework. So it's a link a legitimate link to apps.facebook.com, our app name, which is a fortune-telling application. And the user clicks on it. You can send it to all your corporate email account users. Again, it's legitimate. We're not doing anything funky with cross-site scripting or anything like that. So once the user clicks on it, it gets redirected to the authorization endpoint of Facebook. In this scenario, the user was already authenticated, so they're not being challenged. So we're presenting the access scope. We're basically telling the user, hey, this third-party client app wants to access your inbox. And you would think that, well, most users would say, hey, hell no. I mean, why would I want an app to read my inbox messages? We actually ran a campaign with the Core Impact client. And to our surprise, this many users were fine with this app reading their inbox messages. So once that has been established, as you can see here, we're running basically a simple query, a Facebook query language, which is FQL to read all the inbox messages of the user. We could stop here, but we found one of interest. So the user is talking to somebody else about his banking preference. And we use that, in this use case again, we use that to build a trap to execute our cross-site request forgery attack to post an AJAX PostScript to transfer funds from one account to another. Again, this is a sample banking application. It's not a real app, so we're making some assumptions that there's no CSRF protection and the user has a live session. But the point that we're trying to make here is, once again, OAuth provides the user with a false sense of security around the entire authentication and authorization workflow, because everything looks legitimate as if you were doing this in a trusted domain. And I'd like to know why Facebook would ever let a third-party web-based app to read my inbox messages. That's like giving someone access to your email, I think. Let's shift gears a little bit and talk about a few questionable implementations and insecurities, and then provide some basic, simple solutions to these. So we'll be using Twitter as the main player in these use cases. But that doesn't mean that other providers don't share the same issues. In fact, I think most OAuth developers, third-party or API providers, use Twitter, Facebook, Google as a blueprint to build their own apps. So as you recall in the previous example, Avon wanted to use a third-party client to post something. So it goes through a normal OAuth flow with his Twitter feed, which is a third-party client, web-based client application. He logs into Twitter feed, selects Twitter as the main server, gets redirected to authorization endpoint, provides his credentials, consent is provided, and with the callback URI, he gets redirected back to Twitter feed, and then he sees that his tweet was posted, and everything's great, and he signs out and walks away, not knowing that in the background, his Twitter session remains open. So at no point Avon actually ever went to, and this is Avon, so at no point he ever went to Firefox and typed in twitter.com and his credentials. So this is a problem. It's especially with applications like Twitter that don't have no session timeouts, and the risk or the threat is elevated when the user is in an environment where he's using a lot of different computers, like let's say he's a student and using computers in a lab or dormitory or libraries. He could literally leave a Twitter session open on every computer that he touches to access his OAuth or Twitter account via the third-party client application. Well, maybe you and I don't really care about our Twitter account getting hacked, but what we saw, what happened July 4th with Fox News, we saw some, disturbing messages about our president, and that wasn't cool. Or if you're a celebrity, that could really affect your personality and self-esteem or even physical appearance. You could go from this to this in a matter of days. And this is just not good. Yeah, this is not good. So again, the solution is very straightforward. When, or in use cases where the user was not already logged into the server, by the time you start his OAuth flow, then he should be invalid. His server session needs to be invalidated. So if I'm not already logged into Twitter and I start my third-party client app OAuth flow, and when I'm done with that, when I'm done with Twitter feed and log out of Twitter feed, then my Twitter session needs to be invalidated. And Flickr is doing a pretty good job with this. So every time you log out of Flickr, assuming that you authenticated with your Yahoo credentials, it gives you an option to kill your Yahoo session in the background. How about passwords? You would think that when you change your password, the old passwords won't be used. I mean, that's why I would change my password. Whether they're compromised or for whatever reason, I want to change my password so I can use this new password now to log in. And that's fine. You can do this with Twitter. You can change your password, and you won't be able to get in via the main Twitter login with your old password. But you still have all these third-party client apps that's still using your old password to access your protected resources on your behalf. And that's because in order to disable this, you have to go manually and revoke all your access token on your account profile. Something that a lot of people will not remember when they're changing the password. Right. So the point I'm trying to make is that you use your password to grant permission to a third-party application. So this application can access my protected resources based on the access token, based on the permission I've granted. But the fact that they're doing that is because I've given that permission, and I did that with the old password. So if I'm changing my password, now I have a new password, then that application, in a way, should not be accessing my protected resources. Because the access token, in a way, acts like a password with limited scope. So again, the solution is pretty straightforward. When you change your password, the server should invalidate the access tokens. And Facebook is doing this. I think it was a side effect of a breach that they had, semi-breach, where they leaked a bunch of a bunch of access tokens to various third-party clients. And so now when you change your Facebook password, your access tokens are automatically revoked. Yes? I'm sorry? Well, the refresh tokens, with Facebook, you mean, or in general? Or should they be invalidated? Well, the refresh tokens are not, in a way, sensitive in nature without an access token. So the difference is that the access token is short-lived, let's say 1 hour, if you say you're using Google, and use a refresh token, which is long-lived, to refresh that access token. So if you don't have an access token, a valid access token, then your refresh token doesn't mean anything. And this is the last section of this talk. We're talking about consumer credentials or client credentials. And this is a highly debatable topic in the Auth community. So first thing you do when you build your app, you register your app with a server and get a consumer key and secret, and you embed that in your application so that you can properly authenticate yourself to the server. So protecting these consumer credentials, along with any other token on the server side, is pretty straightforward. Just use your security best practices, isolate and protect with database encryption, file permission, physical security, whatever you like. On the mobile platform, it's a little bit different because you have a large number of devices, each embedding and managing these shared consumer credentials. So this becomes problematic. And the Auth, the contributors believe that, for obvious reasons, that these consumer credentials should not be used for anything other than a statistical needs. Well, sometimes we can't do that. We don't have that luxury. For example, in my case, I had a business requirement where the server had to keep track of all the clients in order to charge them for each API call. And you can always rely on the user's identity because a user could belong to multiple third-party client applications. Or you might want to use the credentials and the trust between the client and the server to do automatic provisioning and deprovisioning of the clients. Or you might want to use these credentials to prevent phishing attacks, because if they're easily compromised or cannot be trusted, then someone can grab them and act on your behalf. So with OAuth 2.0, there's a lot of new flows that were introduced. I don't know, like 6 of them, I think. And some of them doesn't require the consumer credentials. For example, the user agent doesn't require consumer credentials. And that's fine. If you don't need the consumer credentials, don't use them. And obviously not running the risk of having them compromised, but you're not going to meet all my business requirements. And the other option is obviously embedding them into the third-party client app itself. And when you do that, you're running a risk of having them compromised. If you're using an open source client, then you have to embed it in your source code usually. And any of us here can go and do some Google code searches and find several popular third-party OAuth clients with their consumer credentials in there. And that one on top actually has a database username and password as well to go with that. So in my opinion, the biggest business impact here is the whole notion of key rotation and kill switch. So every time the consumer credentials on these embedded mobile devices are compromised, the server is obligated to reissue new ones. So as a client application, you need to re-register your app, get a new set of consumer credential from the server, embed it in your third-party client, and then distribute it to all your users. A process that could take a long time. By the time it's over, you've probably lost a bunch of your customers. And we also talked about business requirements, where the server must keep track of the client in order to fulfill a business requirement or business need, like charge the client for each API call, automatic provisioning, and deprovisioning. Or you might run into a malicious competitor that wants to compromise your consumer credentials and anonymously publish them and in a way perform a DOS attack on your service for a week or two. So let's look at an approach that's a bit different than your typical OAuth flow. We're introducing a few new additional steps here. So the first thing you need to do as a user in this flow, again, this is for mobile. It's a web-based flow for a mobile app. You authenticate yourself to your client's backend server. So let's say the client's Mint, and Mint has a mobile component running on your device and a backend server. So you authenticate yourself to Mint's backend server with your Mint username and password, and you receive a device ID. And this is a new token, a new notion we're introducing here. Once you grab the device ID, you can store it locally on your iOS keychain or just keep it in memory. Then after that, upon that first OAuth call to the server, you need to include that in there as a new auth parameter or embedded in with an existing parameter value. Then once the server receives that, it obviously needs to validate its authenticity, so it makes another call to your client's backend server to make sure this is a legitimate device ID. So by the time you're done, you've added, 5 additional steps, which is a bit expensive, but you only need to do this once upon that first request to the server. And by the time the server is done, the server can be sure that the device ID came from a legitimate user and not a rogue client. So we talked about a bunch of different things here, but I guess the most important thing I'd like to point out is that all the issues we've seen here, they're really implementation concerns and not flaws of the protocol. OAuth is actually pretty good at defeating the password anti-pattern, and without it, we'll be sharing our consumer or our credentials with a bunch of different sites, which is not good. And like everything else in life, just use it when it makes sense. And that's all I had. Thank you.